Okay. There are some caveats that one should be aware of when using regression. If the assumptions are not met, okay, then the statistical test may not be valid. But in this day and age, when there is data is aplenty, so big data, we are most likely not interested in testing hypotheses. We are more interested in predicting values. So the assumptions uh, is not that critical. More critical is our ability to predict more accurately. Now, correlation does not mean causation. That's again very extremely important. Just because two variables are correlated doesn't mean that one causes the other. Now, multicollinearity makes interpretation problematic, as I said. When two variables that are highly correlated are in the model, the coefficients may be um, very inaccurate or problematic. Using the regression beyond the x range is always problematic. Suppose if the x values, so you're trying to predict demand based on price, and the data that you have, the range of price, the x values is say from anywhere between $10 to $15 for that product. And you have data, you fit the model and everything. So if you're trying to predict outside this range, $10 to $15, right? So if you use the regression to predict forecast when price is $20, which is outside the range of x values that you have in the data, so then the relationship may not hold. So you have to be careful when that happens. Okay. The t-test that we talked about, okay, we only use the t-test for the slope coefficients, not for the intercept. The intercept usually is not, oftentimes is not even interpretable. Okay. And oftentimes, even though the hypothesis testing shows that the regression is significant, that doesn't mean that the model that you have is the best model. Okay, maybe there is a different combination of variables, a different set of transformations that will give you better results. So you have to be very careful. You have to approach with a lot of care. Nonlinear relationships can exist if the linear relationship does not. So just because there is a linear relationship is uh, not significant, it doesn't mean that there is no relationship at all in the model in between the x's and the y's. There may be something else there. Yeah. And even though on the flip side is, even though you have a statistically significant relationship, it may not have any practical value because the variance is too high, or some other problems may exist.